what's the domain of this function? Okay, it's kind of what we're ready for. Well, I would just say x is greater than 0 or equal to 0. Okay, so it could be that this function's maximized when x is 0, but there really isn't another endpoint. This farmer could wait indefinitely. Now, in some sense, there isn't another endpoint. You know, if he waits long enough, after large number of weeks, the price per bushel is going to be 0, right? After about 40 weeks or so, you know, we're going to have subtracted 80 cents enough that we're not going to be getting anything for this crop. So, yeah, there's sort of an upper limit as well, but again, the upper limit isn't really an important thing for us because we know that when we finally do get $0 per bushel, that clearly is not going to maximize the value. Okay. So in this case, the first value of x that makes sense, 0, is kind of legitimate. We might think about what the value is when x is 0, but what we're really looking for are critical numbers. If this function has a maximum somewhere greater than 0, 0 weeks into the future, it's going to happen when the derivative of the v function is 0 or undefined. So now we start using calculus. What is the derivative of this function? Well, the derivative of 3600 is 0. The derivative of 24x is 24. And the derivative of negative 3.2x squared is going to be negative 6.4x. Okay. We've got our derivative. It's never undefined, but it will be equal to 0 for the right value of x. So if we add this term over, we get 6.4x equals 24. And so we divide there, we get x equals 3.75. Okay, so it is possible that this value will be maximized 3.75 weeks into the future. Okay. Now, just to be clear that this is a maximum, we should use the second derivative test, which is very easy to use in a lot of the problems. Remember that if the second derivative is negative at this critical number, we know that it's going to be a maximum, at least a relative maximum. So the second derivative of this function is just negative 6.4. So if we place 3.75 in for x, well, of course, there's no x over here, so just get negative 6.4, which is negative. So 3.75 is definitely a relative maximum. Okay. Now, it's probably also the absolute maximum, but I think in this one we should really check. Just to be sure that this function isn't maximized right away, we should check 0 and 3.75 into the value function. We should put both of these numbers in for x and make sure that this is the value of x that gives us the biggest value of our crop possible. Okay, so I'm going to go ahead and erase the derivative because I don't think we'll need it anymore. Okay, but we do have that critical number, and let's write that down. The critical number was 3.75. Okay, so what's the value when we wait 3.75 weeks? Well, I can just put 3.75 in for x in this formula. I'm going to get 3600 plus 24 times 3.75 minus 3.2 times 3.75 squared. Okay. And I'm getting, remember this is a dollar figure, $3,645. So if we wait 3.75 weeks, the value of our crop will be $3,645. Okay. Now, just to be safe, let's just see what the value was initially, right there at the beginning in time. When we wait no time at all, 0 weeks, what's the value of our crop? Okay. Well, if I put 0 in for x here, you'll see that these two terms disappear and we just get $3,600. Okay. So that's not the maximum. Clearly, this point, as we expected it would be, it is the maximum value of the harvest. So this farmer wants to wait 3.75 weeks to maximize the value of his or her harvest. Now, they do ask a couple of follow-up questions in this one. When should the farmer harvest strawberries to maximize the value? Well, 3.75 weeks from now. Okay, so we can go ahead and give a complete answer. In 3.75 weeks, you can say value is maximized. Okay, and what else do they ask? Well, they say, how many bushels of strawberry will yield the maximum value? Well, actually, we can answer that now. If we put 3.75 into the yield component, remember, this is the number of bushels we're actually going to harvest, we can see what the actual amount of strawberries that we will harvest to get this maximum yield. And when I put when I put 3.75 in for x there, so we can say this in 3.75 weeks, Value is maximized harvesting 135 bushels. And what else do they ask? What is the maximum value of the strawberry? So how many bushels will yield the maximum value? 135. And the value of the harvest? $3,645. Value is maximized harvesting 135 bushels, let's say, for a total value of $3,645. Now, they could have also asked us the price per bushel that we'll get, but they chose not to do that. So this is basically what we were looking for here. Wait 3.75 weeks, we'll get the most money we can possibly from the scenario.